Throughout history, fear of change and the unknown has often caused heightened anxiety to countless millions of us in the general public. But if we look closely at history, this fear is often not born out of outcomes. In fact, the past is littered with stories of change that were feared in the early stages, eventually becoming accepted as a necessity, a comfort, or an option. A perfect example of this came early in the 19th century, when electricity would become an essential tool for modern life. The masses were used to lighting candles and having open flames to illuminate the night, with little regard for the danger of fire. But for many, the idea of an entire home being electrified created a new fear of electrocution. In one famous case, it is said that even though President Benjamin Harrison had electricity installed in the White House, he and his wife would not touch the light switches for fear of electrocution, often resulting in them going to sleep with the lights on. Clearly, in the case of electricity, public opinion has changed dramatically, as is true of so many other cases of societal change. Even though initial fear, followed by acceptance, is a known phenomenon, these same old feelings are still very powerful today, especially with our modern world changing so quickly. One societal change that is occurring today that seems to be following the same path are the feelings surrounding the rise and use of unmanned aircraft systems, or UASs. For many, their only experience with these vehicles comes from media reports about them being used by the military for intelligence gathering and defense. Those images, coupled with privacy and safety concerns, is causing some to fear using them back here at home. Many on the front lines of the UAS revolution see tremendous advantages by using these devices in civil applications such as farming, package delivery, wildfire detection, border security, and numerous other uses. Only time, lawmakers, and public opinion will answer the broader societal questions. But one thing is for sure: the technical challenges surrounding these vehicles need to be answered now. Once these vehicles begin to fly regularly here in the U.S., they clearly must be able to work within our current commercial airspace in a safe and integrated way. To make this happen, the government is turning to the world's leading aeronautical organization, NASA, to help develop the framework and lay the groundwork for integration into our airspace. Coming up on this episode of NASA X, we will follow members of NASA's Aeronautics Research Mission Directorate's UAS integration into the NAS project team as they tackle the major hurdles of integrating these types of vehicles into our daily lives. We'll see how researchers are solving technical challenges as well as concerns around human factors in an effort to one day allow these vehicles to safely integrate into our society. Every day, millions of people board planes here in the U.S. For most of us who travel by air, we don't think much about all the systems in place to make our flights as seamless and easy as most are. We travel from destination to destination with little thought of all the people, equipment, and regulations put in place to make our national airspace system the safest in the world. Airports, air traffic controllers, towers, communication systems, maintenance crews, and thousands of other moving pieces, along with regulations, are all key elements that allow for relatively smooth and safe operations for the nearly 50,000 flights that take off and land in the U.S. every day. Our National Airspace System, or NAS, is incredibly robust, and in fact works so well because everyone who works within the system understands their role and the procedures that have to be laid out. But when you have a system that works so well and is so vitally important, the idea of making fundamental system-wide change can be daunting. And one of the biggest changes that will be confronting the NAS shortly is the inclusion of unmanned aircraft systems, or UASs. The FAA has strict rules outlining all aspects of piloted flight, but with no pilot inside a craft, changes will need to be made to make sure these systems are as safe and robust as possible.
Safety is always in the back of our mind, and having these systems that can be just as safe as the manned aircraft, which we have the safest air transportation system in the world. And so as the FAA takes these new technologies, introduces those into unmanned aircraft and introduces those into the NAS, that safety will not be compromised. We are doing this and making sure that then when the FAA assesses the technologies and assesses any airframe and the avionics that they have or the sensors that they have on board, that those are going to meet the same sort of standards, maybe not the same exact standards, the same sort of standards that they've established for manned aircraft. So safety is always in the back of our mind, and it underpins every decision we make and everything that we do.
The task is definitely daunting. We focus particularly on procedures and standards. So from the procedure side, the FAA has built a very, very safe national airspace system. Accidents essentially don't happen. A lot of the rationale for that is procedural. Our air traffic controllers know what they're doing, they know how to manage their airspace, and bringing UAS into this system changes things. What we're trying to do is help inform procedural development so that the FAA can take our inputs and integrate them into their new air traffic control system as they develop their next-gen infrastructure.
This is one of the reasons NASA has such a large role in the UAS integration into the NAS. NASA has decades of understanding how to build a system as complex as this into a functioning reality.
But the reason why NASA is involved is pretty much consistent with what NASA does across the board. I mean, NASA is looking for investments in research areas that will enhance the quality of life of your everyday person. And so that applies in the area of aviation, that applies to things like looking at how we can fly airplanes faster or use less fuel or do something positive for the environment while still flying over that environment. So we've been doing those kinds of things in aeronautics all along, and unmanned aircraft systems is just another new technology that has the potential to enhance people's quality of life.
NASA planners laid out a game plan to tackle the major issues involved in integrating UASs into the NAS. Their plan is to focus on 4 major technical barriers to make this transition possible. These 4 include sense and avoid, command and control, human systems integration, and integrated test and evaluation. The Sense and Avoid challenge is focused mainly on the see and avoid problems UAVs have because there is no pilot in the cockpit. Technology will need to be developed that will, in essence, replace the pilot's eyes with incredibly accurate radar, helping UAV pilots on the ground avoid any nearby aircraft. The Command and Control Challenge will develop a new radio system that will be integrated into the NAS, allowing for reliable and secure communications. The Human Systems Integration Challenge is essentially a human factors challenge that will help configure uniform ground control systems and displays to enable ground station pilots to work effectively. And the Integrated Test and Evaluation Challenge will provide a relevant environment, which will allow researchers to integrate different components of the system and test them in a virtual environment, then into real test flights. Each one of these technical barriers have their own unique and challenging issues, but due to the complexity associated with integrating each of these into one system, NASA planners are working jointly on these issues to ensure proper integration.
If you know a little bit about systems, you know you can't take different elements of a system and you can exercise them and test them, but if you don't combine them into an integrated flow, you miss those little things and they don't really work well. So we don't want to just go out and have a lot of silo sub-projects. Those systems all interact and integrate within each other.
With this collaborative plan in place, NASA's 4 aeronautics centers are working jointly to make this goal a reality.
So the community working on unmanned aircraft systems is large. It includes Department of Defense, it includes Homeland Security, it includes a significant number of people from the FAA, and lots of people in industry working on standards. NASA has a relatively large hand in this also. We've got 4 centers working on it. Our 4 technical challenges are spread across those centers.
Let's first look at the Command and Control Challenge that is being led here at NASA Glenn Research Center. Here is NASA's Jim Greiner.
Before this project began, NASA surveyed the industry and other government agencies in order to determine what areas need to technology development for unmanned aircraft to be integrated. 2 of those areas were separation assurance, how to keep aircraft away from each other, and the other area was communications, how to make sure we had a reliable, secure communications link between the ground and the aircraft. So we work with industry to develop the program that we're actually employing today. So what technologies we need to develop and the performance requirements of those technologies to make sure that those systems were robust and sound. So we have been working alongside industry in performing testing to enable those standards to be written for commercial entities to be able to certify equipment to put in unmanned aircraft. Unmanned aircraft are pretty much like standard aircraft that are flying today, although they range from very small up to very large aircraft. But what we're trying to do is take the pilot out of the cockpit and move that down to the ground. So normally there's wires and other cables connecting the pilot to the aircraft. Now we're actually taking that cockpit, putting it on the ground, and we're flying that with a wireless system. So it's really like a fly-by-wireless type of system that we have flying the aircraft now. And so that communications link, which is what I'm developing, has to be very reliable. I mean, just as reliable as those wires that we're connecting it on board the aircraft.
Because the FAA has stringent rules in place about flying in the NAS, the communications team at Glenn is using a surrogate aircraft to help with the tests. Although this T-34 aircraft can be flown from the ground like an unmanned aircraft, there is in fact a pilot sitting inside the cockpit to monitor the flight during this initial testing phase.
In order to fly an unmanned aircraft in the National Airspace System, you have to go through a long process to get a waiver to fly in that area. It's very restricted. I mean, usually sparsely populated areas and areas you may not be flying an unmanned aircraft in the future in. So with us using manned aircraft, we can fly anywhere in the National Airspace System where that aircraft normally operates. And that allows us to test in a realistic environment where we expect unmanned aircraft to actually be flying in the future, rather than being restricted to portions of the desert or something where we may not see a lot of unmanned aircraft flying in the future. We'll be integrating the multiple technologies from the UAS project as a whole together and flying those all as one mission. So there'll be a real pilot at the ground control station developed for this project, as well as my radio link, and then algorithms on board the aircraft for the separation assurance portion of the test. So all of that in concert lets us fly the aircraft, because the aircraft will be in a surrogate type configuration, so the commands from the ground control station will actually be maneuvering the aircraft. So in that, it's a full end-to-end test in a realistic environment. The testing we're doing is helping enable a whole new industry for unmanned aircraft, because without this, civilian aircraft will not be able to fly in the National Airspace System. NASA has all the correct facilities as well as the personnel involved in order to be able to do this testing. There's been a long history with aeronautical communications here at NASA Glenn that we've been working with the FAA and industry on many occasions before, and other centers have also been working closely with the FAA on their particular technologies related to UAS, and those all came together within this focused project in order to bring those technologies to fruition.
If you look at unmanned aerial vehicles of today, one of the biggest concerns comes from the fact that they cannot sense and avoid oncoming traffic autonomously, which clearly represents a significant mid-air collision hazard to other aircraft operating in the same airspace. Here, at NASA Langley in Hampton, Virginia, members of the UAS team are working diligently to make this concern a thing of the past. One of the biggest challenges facing the integration of unmanned vehicles in the NAS is separation assurance, or sense and avoid. Understanding these variables and developing the automation to help pilots make the proper decisions while navigating is challenging. Part of this challenge comes in working through integration issues with air traffic control, pilots in the air, and UAS pilots on the ground. With that in mind, the NASA Langley team has put together sophisticated testing environments, which will allow pilots, air traffic controllers, and researchers to work collaboratively in the confines of the Air Traffic Operations Lab, or ATOL. This team is coming up with procedures for pilots from unmanned stations to communicate and interact in the most effective way with air traffic control and other piloted aircraft. Although the ATOL is physically located at NASA Langley Research Center, a component of this work is also being handled by a team at NASA Ames, located in California's famed Silicon Valley. Here, the UAS team is working on both sense and avoid and human system integration.
My area is human systems integration, and so I work on the ground control station where the pilot or the operator sits to control the UAV. And our work with integration in the NAS is really trying to understand what the minimum displays are, what the information requirements are for that operator to safely operate in the national airspace. And so we've been doing work with the FAA, with RTCA, Special Committee 228, to help develop the guidelines for what the minimum information requirements are for UAV operators to fly in the NAS. We're really primarily integrating technologies that exist today and looking how that they come together in an integrated system to be able to address this need. For example, we're taking onboard radars integrated with other surveillance systems to be able to ensure that the operators can perform see and avoid functions that are currently done visually by manned aircraft. And so it's primarily an integration of existing technologies and developing the requirements and testing those requirements to ensure that the UAVs can safely fly in the NAS.
You start with what the UAS is. The UAS is a remotely pilot vehicle. However, there's a lot of safety built around the fact that in manned aircraft, the pilot is looking out the glass and is the last line of defense. Hence, sense and avoid, self-separate. So what we're trying to do is we need to do research to integrate the fact that there's a pilot on the ground performing that function, and how does that integrate with separation assurance? That means the air traffic controllers that are separating manned aircraft safely as you transit through the airspace. How does that play with the primary role of air traffic control? Does it perturb their workload? How does it affect them in their day-to-day jobs as we integrate more aircraft into the airspace? There's also implications of what are the effects on other aircraft that are flying. There's a system equipped on every manned aircraft that's certified to fly over 10,000 feet. It's called TCAS. And this is a last line of defense to prevent collisions. Well, the sense and avoid system has to interoperate with that system. It has to play nicely. So specifically, my team is looking at the barriers and the integration challenges of integrating UAVs that are trying to propagate through the airspace system safely, and how that affects other agents, other users of the airspace, and as well as the regulators, the air traffic controllers that are providing the separation services.
Just a few hours down the road from NASA Ames, the culmination of much of this integration happens here at NASA's Armstrong Flight Research Center. Since the earliest days of flight, this lake bed in the high desert has been used to test virtually every type of aircraft imaginable. This storied research center is where much of the flight testing for the UAS integration into the NAS will take place. The final challenge is IT&E. Here is NASA Armstrong's Sam Kim to explain.
IT&E stands for Integrated Test and Evaluation, And that sub-project deals with taking the research that a project is developing, all the software, the algorithms, the procedures, and putting that into a relevant environment. That relevant environment entails simulations that replicates the real world as high fidelity as possible, but then ultimately we need to take that to a flight test environment and to be able to validate the results. As the word integrated like entails, right, in IT&E, the integrated test and evaluation, it is an integrated effort to take all the elements of the 4 sub-projects that are part of the US and the NAS project and trying to get those into an integrated environment. So yes, we need to make sure that all the systems play together, and more importantly, that they really replicate the real world as close as possible. So ultimately, like I said, it goes from simulations into flight tests. So the research ground control station you see behind me is one of the manifestations of that capability to integrate things. It is a proof of concept ground control station that embodies all from the human factors and some of the self-separation technologies that we're developing. It's embodied in this proof of concept GCS. In this RGCS here, we do bring in pilots, so we actually bring in real UAS pilots. In fact, we've not just used NASA research pilots, but we've also used Air National Guard pilots and been able to have a diverse evaluation of our systems. So yes, we bring the pilots here, they get immersed in the simulation environment, and then we're able to collect meaningful data that says that whether systems we're designing present the right information and whether they can assimilate that data quickly and be able to react to the national airspace flying.
When the integration is complete, many of the so-called dull, dirty, and dangerous missions will be turned over to these UAVs, paving the way for a new, safer way to monitor important tasks. We are not there yet, but it's clear that the UAS challenges that have been laid out are daunting. It is also clear that the brilliant men and women of NASA are rising to the challenge as only NASA can. Thanks to their pioneering work, we will soon have a new type of tool available to humanity that will almost certainly prove to be invaluable by making our world and skies safer and perhaps even better than we ever thought they could be.